Hi, my name is Matthew Lewis. I'm a Field Applications Engineer for Sierra Wireless, and I'd like to introduce to you a way that Sierra would like to propose you design a telematics box for fleet management, stolen vehicle recovery, insurance pay-as-you-drive applications, and eCall. What are the requirements for these types of applications? Well, there are two primary requirements. The first one is GPS. All of the applications need to know where the car is, how fast it's going, direction, things like that. Okay. The next requirement is to have the ability to send the data from the unit back to the server. Okay. For this, you would need IP to make sure it's future-proof, version 4 and version 6. In addition to that, you'll need the wireless technology to provide that backhaul capability, to provide the basic bearer. Okay. So that would be GPRS, Edge, or whatever flavor of 3G that you wanted. In addition to the two basic requirements, there are other application-specific requirements. Okay, so an example of that might be in the audio area, where these black boxes sit behind dashboards and they just operate without the drivers knowing or having any interaction. Okay, so you may want to, for instance, provide some form of interaction whereby you will provide simple voice prompts such as, "You've been driving for 2 hours, please be careful." Okay, or recommending that they may want to stop. Okay. In addition to this, you may want to have the ability to record audio over any audio paths that are available. Okay. So, for instance, the last 5 minutes of audio in a vehicle cab before a crash may be very relevant for assigning blame in the case of a crash. Okay. If you're designing an eCall box, then you will need an in-band modem. Okay. This will probably be the 3GPP specified modem, in-band modem. Stolen vehicle recovery will require jamming detection. So if someone walks up to a car, turns a jammer on, then you can detect it, and if you have a radio beacon system as part of your system, then you can send a warning over that bearer to your service centre and notify the owner that a vehicle may be being stolen. Okay. Finally, there's other standard technology that you may want to interface to. So the Bluetooth in the car hands-free, Wi-Fi interface. So if there's Wi-Fi on board the car already, or if you want to provide the car with a Wi-Fi hotspot. Okay. The CAN bus. There's a lot of information, a lot of telematics information that's going around the CAN bus all the time, such as RPM of the engine, which you may want to monitor and also record as part of driver behavioural analysis. And then finally, there are other sensors that you may have on board your actual application. So, for instance, accelerometers. Okay? These are primarily used nowadays for crash reconstruction and crash detection as well. How do you go about designing one of these applications? So the traditional and classic approach is to do it using discrete components. So for that, you would need to design using a microprocessor, be it from a small PIC device, all the way up to an ARM9. Okay? And depending upon what you want to implement, you may need to design in an additional memory chip as well, depending upon whether you want to implement some of the features that we've talked about earlier, such as the audio recording. Okay. Subsequent to that, you also need to implement a modem and a GPS as well. Okay. Once you've combined that into a single hardware on a PCB, or alternatively with daughter boards, as you may or may not want to design it, you then have to start your software from scratch. Okay. This is a huge amount of integration work, which most people tend to underestimate. This isn't a terribly space or cost-optimized solution. Both of these factors are extremely important in solutions that are being presented today. The space is of extreme importance because most of these applications are battery-powered, and you need as much space as you possibly can to get as large a battery as you can into the box. In addition to that, for stolen vehicle recovery, having a very small unit is important so that you can hide it somewhere on a car. Okay? So any time that you can save in this particular design phase, you can spend, alternately, developing value-added services, which is where you yourselves will make your money. So, how does Sierra Wireless propose that you move away from this traditional way of implementing applications of this nature? Okay. We're proposing that you embed the application on board the wireless module itself. All of our units have an ARM9 chip on board, okay, so they have plenty of power to be able to devote time to your application code. Okay. We refer to this as the OpenAT framework. Okay. Now, the OpenAT framework refers to a set of development tools and APIs that we supply to you as part of our firmware free of charge, and you can use it or not as you see fit. Okay. OpenAT itself is written in C, which is standard within the embedded industry. The operating system supports multiple hardware interfaces depending upon the module that you've chosen. Okay. These include multiple UARTs, SPI interface, USB, and GPIOs, and you can use these as you see fit. The software features that we've implemented are relevant to these types of applications are things like our location plugin, which is designed to work with a GPS chipset to provide you all that sort of level of functionality that you need. An IP library or an internet library which caters for protocols from IP all the way through up to HTTP if you so wish to go that far. Okay. In addition to that, there's an eCall library for the in-band modem, as was mentioned earlier. Okay. That is to the 3GPP spec. And then we've also got a jamming library, a jamming detection library, okay, to react to any jammers that are turned on in the vicinity of the unit. Moving on to the development environment itself, okay. The development environment is based on Eclipse, which a lot of developers nowadays are very familiar with. Okay. It enables you to open multiple projects, view them all, port code, switch between different operating systems if you're using different firmware versions. It enables you to design, develop, debug, and download all of your code onto the units themselves. Debugging is a very, very strong concern of most developers when entering into an environment like this. To cater for this, we've embedded a GDB stub inside the firmware of the unit. This enables you to download firmware onto the unit, set breakpoints. Once those breakpoints are hit, obviously the unit will stop. You are able to step through code, step into code, look at the assembly code underneath the API itself as well. You can then also, if you are facing timing problems, run real-time logging as well. Okay. Then if the worst happens and the unit actually crashes, then you can look at back traces. So when the unit crashes, it will write into memory the location of the function where it was last, and you can try and figure out from there, or at least focus on that area of code, what caused the problem. There are multiple use cases that all of the APIs have been designed around. Primary to this, particularly in the vehicle telematics market where power is so important, both when the vehicle is off and when you're potentially running on emergency power through batteries, are the power save modes. There are power save modes to take into account having an IP session running back to your server, so you can have the unit running in 32 kHz mode, and you'll still have that session up and running, no data being sent, but if the server wants to contact the unit at a moment's notice, then it can, and the unit will automatically fire up into 26 megahertz operational mode, deal with any data as you've written your code, and then power back down into 32 kHz mode, where it's consuming around about 3 to 5 milliamps. Other things that we've implemented are automatic wear leveling of the flash, and there are other power save modes for the individual GPS chip to ensure that you get a fast time to first fix as well, which is critical in these applications. Thank you very much for your time in listening to this tutorial. If you want further information, then please contact either your local Sierra representative or go to developer.sierrawireless.com.